Lesson 2.6. Draw scatter plots and best fitting lines. A scatter plot is a graph of many data points and often look like they're scattered all over the graph, hence the name scatter plot. Sometimes the points make patterns, and if they appear to make a line, we'd say there's a correlation. A positive correlation would be if the points appear to make a line with a positive slope. A negative correlation would be when the points appear to make a line with a negative slope. And no correlation is when there's no obvious pattern from the scattered points. The correlation is measured by the correlation coefficient, which is an R. Correlation coefficient is always a number between -1 and 1 that measures how well the data fits a line. Both -1 and +1 are a perfect line, whereas 0 is no correlation. Positive correlation coefficients for positive correlations, which were positive slopes. Negative correlation coefficients for negative correlations and negative slopes. R equals 0 means there's no correlation. For each scatter plot, tell whether the data has what type of correlation they have and estimate the correlation coefficient. So for the first graph here, you can see the points appear to be going upwards to the right. Kind of like that. So it's going up, it's kind of a line. Would say there's a positive correlation, but it's not a perfect line, so we'd say that R is about a half. On this one, you can see there's an approximate line going downwards. That's a negative slope, and the points are very close to the line. So it would be a negative correlation, and R would be approximately -1. This one, the points appear to be scattered all over the place. There's no real line anywhere. So we would say there's about no correlation, so the R should be about 0. If the points form a line, we often want to know the equation of that line. We call that the best fitting line, which is the line that most closely approximates the data. To find the best fitting line, first of all, draw a scatter plot of all your data. Then, sketch the line that appears to follow the data the closest. You need to use a graph paper and a ruler to do this well. When you draw your line, there should be approximately as many points above the line as below the line, so that your line goes right through the middle. Next, you choose 2 points on the line. These 2 points could be original data points, or they could be points your line goes through that were not part of the original data set. You just need 2 points on the line. It is best if you choose points that are far apart. Use those 2 points to find the slope and then get the equation of the line. So again, these points do not have to be original data points, and it's better to choose points that are far apart from each other. So here's an example. Monarch butterflies. Every year the monarch butterflies fly south to Mexico for the winter. And the area they have been using to winter in has declined. So our table shows the number of acres, which is Y, that the butterflies use X years after 2006. So that means when X is 0, it's 2006. When X is 1, it's 2007, and so on. And we need to find the best fitting line for the data. Start by plotting all the points. Then draw the best fitting line. See, the points appear to be going downward. Draw a line that essentially has the same number of points above and below. Something like that. Find the equation using 2 points, and I chose the 2 points, the x and y intercepts, because I could tell what they were. But you could choose any points in between, so you could use maybe this point right there if you wanted to, and this point right there. I just chose the 2 intercepts. So use the slope formula to find the slope, which is negative 1.875. And I know the y-intercept just by looking at my graph. It's about 15. So I can just plug this into y equals mx plus b. I know the slope, I know the y-intercept, fill in the numbers, and that's the equation of the best fitting line. Now, if you used a calculator, you would discover that this is close, but not exactly the absolute best fitting line. Since we are doing this by hand, we will be getting approximations. So you should be close, especially your slope should be close. But it may not be exact. Now use our equation to predict the area used by the butterflies in 2016. 2016 is 10 years after 2006, so we will let x equal 10. Fill that into our equation, and you'll see that y is negative 3.75. A negative area would indicate they've gone extinct. Thankfully, it's after 2016, and they have not gone extinct. Thus, this is not a model that actually shows real life. And here is your assignment.